Okay, so the problem I'm about to do is the dragon problem from the unit on exponential modeling. Okay, so this is going to help you learn how to apply what you know about exponential functions into some real world problems like dragons in Greenland. So, the problem says that when dragons were first brought to Greenland last week, they had no natural enemies, so their numbers increased rapidly. Assume there were 50 dragons on April 25th, and that by April 28th, the number had increased to 500 dragons. So in other words, after 3 days, it had been multiplied by 10, okay? Assume that the number of dragons increased exponentially with the number of days since April 25th, okay? Part A, use D to represent number of dragons. And T to represent elapsed time in days since April 25th. So I'll write days since April 25th. Okay? So those are our two variables. Now we're going to write the equation assuming an exponential function. Exponential functions have a general form of y equals a times b to the x. B is the multiplier. It's the value we're multiplying y by every time x increases by 1. And a is the starting value, okay? The value of y when x is 0. So in this case, we're given some information in the paragraph that gives us, it allows us to extract some ordered pairs, okay? So if the independent variable is defined as the number of days since April 25th, then on April 25th, then that independent variable would be 0. So on April 25th, there were the 0 days since then. So we have the point 0, 50. There were 50 dragons on April 25th, okay? Then there were 500 dragons 3 days later on April 28th. So we have those two ordered pairs. Now we've got to come up with an equation. Well, this is our A value, okay? A equals 50. You're not always given the starting value, but if you are, it makes for an easier problem, all right? So the starting value is 50, so we know that's A. Let's plug it in. Now, the multiplier is not 10. It might appear to be 10 because we've multiplied 50 by 10 to get 500. But what the multiplier in the function represents is the change in y, that what you're multiplying y by for every increase in 1x. So for every 1 day, what are we going to multiply the number of dragons by to figure out how many more we'd have the next day? Okay? So it's not that every day we're multiplying by 10, it's every 3 days we're multiplying by 10. Okay? Now I know that that has something to do with the cube root. We've jumped up by 3 days. So the answer is going to be the multiplier will be the cube root of 10, not just 10. If that was a 1, the multiplier would be 10. Our equation would be y equals 50 times 10 to the x. But it's not, it's 3. So it's y equals 50 times the cube root of 10 to the x. I know that because I've been doing this for a while. The safe way to find out the multiplier is to plug in the other ordered pair. So we have 50 for A. We don't know B. Plug in 3 for x and 500 for y. And solve the resulting equation for the base. That is going to be the multiplier in your equation. Divide by 50. And now raise both sides to the reciprocal power, to the 1/3 power, or cube root. And we get the cube root of 10 for B. Now, if you have a calculator, you might want to punch in cube root of 10, find this as a decimal, and then store that decimal for future use, okay? But that's the multiplier, so I'm going to write the equation as y equals, nope, talking about dragons and time, so D, or D of t, equals 50 times the cube root of 10 to the power t. And that's my equation. Right? That's the equation I would use. That's the answer for part A. And it's very important to come up with an equation before you're asked other problems because this is going to be a lot easier to work with now. So this is the dragon problem. This is letter A. Let's find the equation. Let's now use that equation to answer some more problems. So part B. How many dragons would you predict on May 1st? May 1st, that is 6 days since April 25th. So let's plug in 6 for t in this equation here. So we have, in other words, d of 6 for May 1st is going to be 50 times the cube root of 10 to the 6th. Move this over a little bit. Okay? Now, if you had the decimal written here, you wouldn't get exact values. You would get something a little bit off, and that's okay. All right? If you're using decimals, please round to the nearest thousandth, as we do pretty much all year, to 3 places. But you'll get an answer that's 5 or 6 dragons from the actual answer. But as long as you show your work, you're going to be okay with that. D of 6 equals, well, the cube root of 10 is 10 to the 1/3. 10 to the 1/3 to the 6th becomes 10 to the 2nd. So this is just going to be 100. 100 times 50 is 5,000. So the answer for part B is 5,000 dragons exactly. You would have gotten something like 4,993 if you used the decimal version of cube root of 10 as your multiplier. Okay? The last problem asks about when, so you're going to find t given the number of dragons. Let's go over here. Sorry about that. For part C, very low-tech video, obviously. Sorry about that, folks. For part C, we're going to use the same equation, d of t equals, I'll just rewrite it over here, 50 times the cube root of 10 to the tth power. And now we're just going to solve for t, given the number of dragons. D of t is 5. Okay, you're solving an equation for the exponents. Chances are you're going to need to use logarithms. Okay, and here we do. You might see a pattern. You might be able to tell that April 22nd is going to be the answer because 5, there were 50 on April 25th. There were 500 on April 28th. So it just kind of makes sense that there's going to be just 5 3 days before April 25th, on April 22nd. But let's show some work, show the algebra and how we get April 22nd. So to solve this problem for the exponent, I would divide by 50 to start. I think everyone should do that. And we get 1/10. 0.1 equals the cube root of 10 to the tth power. Now, if you recall the most recent quiz, we're now solving an exponential equation, all right? And yeah, we could use logs. Our answer, we could do this. T equals the log of 1/10 divided by the log of the cube root of 10. I don't have a calculator up here, though, but I'll write that, the log of 1/10, so 0.1 or 1/10, whatever, over the log of whatever the cube root of 10 was as a decimal. And we will get -3. So that means that the answer is going to be April 22nd. But you don't need to use logs in this case because you can write both sides of the equation with a common base, just like the last quiz. 1/10 is 10 to the -1. And the cube root of 10 is 10 to the 1/3. So we have 10 to the -1 equals 10 to the 1/3 to the t becomes 10 to the 1/3 t. So now our equation is -1 equals 1/3 t. -1 equals 1/3 t. From that point, I would just multiply both sides by 3 to get the positive 1t. And we get 1t equals -3. So that implies April 22nd, right? Oh my gosh. Wow. It's because that I was writing 2 2s, so I jumped ahead of myself. I wrote 2 L's in April. Oh no. Wow.